Anyway, cool. So now we can move on to the big topic for the day, and that is multiple. Oh, it's just twisted. There we go. We're working out the kinks still, people. That is multiple quantifiers. Multiple quantifiers. Is someone getting an old timey phone call? There you go. So right now, everything we've done so far has pretty simple statements, right? We're just saying that for everything in this domain, this happens, or there exists something in this domain where this happens, right? So those are two kind of very basic statements. The real world, well, actually, we're not in the real world, but the real mathematical world, right, that I love to live in, isn't usually that simple. Usually statements, if you're trying to say anything of note, of merit, right, you want that research grant, it's going to be something a little more complicated. So, for example, right, you could have multiple there exists. So you could have a double there exists. So you could have, let's write down the options. So if you have two quantifiers, you could say something along the lines of there exists an x and d, right, such that there exists a y and c, such that p of x, y. So this is a statement with multiple quantifiers. This is one way we can go, right? There's two there exists combined together. And notice this p of x, y, this is just a predicate with two inputs. You saw as nested if statements and comp sci. Ooh. Well, right now we don't have an if statement yet, but the question is if we did have an if statement. Really what this would be is like if you have two for, like, this is kind of like more like a nested, like if you're trying to prove this is true, this is more of like a nested loop, like a while loop or a for loop or whatever, where you're going through both the domains, right? It's like you're going through the D domain, and then you're going through the Y domain, right? You're trying to find just one in the X and one in the Y, but these both happen to be true. That's how I think about it instead. But yeah, so this is a there exists statement, and it's just saying there exists an X and D, there's just a Y and C, so the P of X, Y happens to be true. So let's do an example. So for example, I'll say there is a country in Europe where there is a panda named Peter. I don't know if it's true or false, but I'd bet on it, right? That feels like something they would do. So there's a country in Europe where there's a panda named Peter. And so the way we can think about this is, let's go ahead and so writing this in math, we say there exists, I'll say a country in our set of European countries such that there exists a P in the set of pandas, right, such that I'll say Q of CP is true, where we'll define Q of CP. How do we define this double variable predicate? So right now we just have the setup, right? We have C is a country in Europe and P is a panda. Right? To drive it home, what is this sentence saying about this country in Europe and this panda P? Nothing? I am saying that P. What about P? Where's P live?
In the European country C.
Yeah, in C, perfect. And
Is name Peter?
his name Peter. Thank you very much, class. Yes, yes, right? So here we have a double variable predicate, Q, which is true if P lives in this country C and is named Peter. Right? And all this is saying is that there's some European country and some panda where Q is true. Some European country and some panda where P does live in that country and is named Peter. Does that make sense?
Yeah, that makes sense.
Yeah. Cool. So that's a there exists statement. That's like a double there exists. Yeah, then let's do. I mean, another one would be. There is an X in the natural numbers such that there is a Y in the real numbers where X to the Y equals 1. So all this is saying is that what? There exists an X in natural numbers is that there exists a Y in the real numbers such that X to the Y equals 1. Oh, you guys can see that. Help a guy out. There we go, yeah. So this is a more mathematical statement, right? Oh, I forgot that there exists here. Yeah. Any questions on this? And is this true, by the way?
Yeah.
What's your example, Safa?
If you raise it to the 0 power, it will usually equal 1.
Yeah. And so we're saying there exists, right? We're saying that there exists one case where this is true. So all you gotta do is find 1. 1 and 1, I like it. So let X, so let X equal 1 and Y equal 1. Notice X is the natural numbers, Y is in the real numbers. No X and natural numbers and 1 real numbers. Then X to Y equals 1. So you're proving that there does exist 1. Okay. Here's the key though. These there exist statements are all, if there's 2 there exists, did we really need the 2 there exists? I mean, why not, like, could you think of a way to say this with only 1 quantifier? Yeah, you can just combine with an and, basically. So this statement right here, well, we'll get to that next time. We'll get to that next time. But for now, let's just talk about this. Does the order matter? So here I said there exists a country in Europe and this is a panda, and there exists a panda such that QFCP, such that that panda lives in that country and is named Peter. What if I went the other way around? What if I said there exists a P in the set of pandas such that there exists a C in European countries such that Q of CP. Are these two statements equivalent? What do you guys think? I mean, just in this. Yeah.
Since you were saying we could combine them with an and, shouldn't it mean the same thing then, since like P and Q is the same as Q and P?
Yeah, that's kind of a decent way to look at it. The point being here, right, that this should just kind of make intuitive sense, right? Like, if there's a country in Europe and a panda in that country, or if there's a country in Europe and a panda, such that panda lives in that country and is named Peter, right? Well, that means we know that there is a specific panda in this specific country where it lives there and is named Peter, right? All this means is we found one, right? All this means is that we found a C in the countries and a P in the pandas where Q of CP is true. It doesn't matter what order we find them in, right? These are equivalent. And it's not just in the case of pandas and countries, it's always equivalent. So what we got right here is this is going to be equivalent to there exists a Y in C, such as there exists an X in D, such that P of X, Y. Always equivalent. Doesn't matter what order you find them in. The point is we found a specific X and a specific Y that satisfies P of X, Y. Make sense?